Today we are going to discuss factors affecting angle of deviation of a prism. Deviation produced by a prism. The angle of deviation, that is the deviation produced by a prism, depends on the following four factors. First is I, angle of incidence. Second is refractive index of the material of the prism, mu. Third is angle of prism, A, and fourth is wavelength of light used, that is lambda. So these are the four factors on which the angle of deviation depends. Angle of incidence I, refractive index of the material mu, angle of prism A, and wavelength or color of light lambda. So let us discuss how the angle of deviation depends on angle of incidence. This is the first one we are going to discuss. So if for different angle of incidence I, we measure the angle of deviation and we plot it graphically, then we get the nature of graph like this. It means with the increase in angle of incidence, angle of deviation first decreases, reaches to a minimum value. This is the minimum value of angle of deviation, that is denoted by delta m, and this is the corresponding value of I for which the angle of deviation is minimum. So with the increase in angle of incidence, angle of deviation first decreases, reaches to a minimum value, and then again with the increase in angle of incidence, the value of angle of deviation increases. This is how the angle of deviation changes with the angle of incidence. So at this position delta m, that is at minimum deviation position, remember these are the conditions satisfied, that is ABC is a prism, suppose P, Q, R, S are the different rays. Suppose PQ is the incident ray, QR is the refracted ray inside the prism, and RS is the emergent ray. Remember, when delta equal to delta M, in that case QR will be parallel to BC. That is, the refracted ray inside the prism is parallel to the base of the prism. Naturally, in that case, angle of incidence I and angle of emergence E both will be same. I will be equal to E. So these are two very important conditions, and one more condition. Suppose this is R1, this is R2. Then the third condition satisfied is R1 equal to R2. So once QR is parallel to BC, then these two conditions can be satisfied geometrically. So we have to remember, at minimum deviation position, the refracted ray inside the prism is parallel to the base of the prism. Now we have the equation A plus delta equal to I plus C. We have derived this equation in our previous lecture. Now let us see what change we find at minimum deviation for this prism, for this formula. So this formula A plus delta equal to I plus E. If delta equal to delta M, that is at minimum deviation, we get I equal to E. So the formula can be changed as A plus delta M equal to I plus I. So A plus delta M is equal to 2I. So what is delta M? That is 2I minus A. So we can say at minimum deviation, this delta M is equal to 2I minus A. Now second factor on which it is depending is the refractive index of the material of the prism. Okay, mu. How it depend on mu? Remember, it is found that for a given angle of incidence, The prism with higher refractive index produces greater deviation than the prism which has lower refractive index. It means you can say it is directly proportional. Directly proportional. It is directly proportional. Next factor is angle of prism. Angle of prism means denoted by A. Angle of prism is denoted by A. So we can say about angle of prism, it is found that the angle of deviation delta increases with the increase in angle of prism. So this is also directly proportional. This is also directly proportional. We can say as the angle of prism increases for any given angle of incidence, the angle of deviation depends on angle of prism. For any particular angle of prism, the prism with higher angle will produce more deviation than the prism with lower angle of incidence. Now the next factor is lambda, that is wavelength or color of light. The refractive index of a given transparent medium is different for the light of different colors. It decreases with the increase in wavelength of light. Thus, refractive index of the material of the prism for visible light is maximum for violet. Maximum for violet means you can say mu violet is greater than mu r. It means refractive index of the material of prism is more for violet color and less for red color. That's why the angle of deviation delta for violet color is greater than angle of deviation delta for the red color. So we can say that the prism deviates the violet light most and red light least.